So hello friends, in today's video we will discuss about CFIM2 Compact Fiber Interconnect Module Type 2. So this is the pack code of CFIM2 and CFIM stands for Compact Fiber Interconnect. 2 is for module type 2. So NTK504QB is the pack code for CFIM2. So in today's video we will discuss about CFIM2 in details, how CFIM2 is internally connected with each other with the MPO ports, and how CFIM2 is used to connect with different RLS, and CFIM2 is how it is used to connect with CCMDs. So we will show all these different connectivity within the compact fiber interconnect module with other equipment as well. So let's start. So this is the CFIM2. You can see here this is the CFIM2 physical view. You can see this is the equipment inventory, and these are the MPO ports 1, 2, 3, 4, 5, 6, 7, 8. So here in CFIM2 is for 8 MPO port. So you can see here CFIM2 NTK504QB. This is the physical view. So physically it looks like this. You can see here this is the line diagram. You can see MPO port 1, 2, 3, 4, 5, 6, 7, 8. There are 8 MPO ports in CFIM2, and you can, if you notice, you can see MPO port 1 is connected to MPO port 5, 6, 7, 8. In the same way, MPO port 2 is connected to 5, 6, 7, 8. MPO port 3 is connected to 5, 6, 7, 8, and 4 is connected to 5, 6, 7, 8. So in next slides, I will show you what is the significance of this and how it is used to connect and what are these blue lines. So we will discuss in detail. You can see this is the internal connectivity. This is CFIM2 NTK504QB internal connectivity. So MPO port, you already know that MPO port here are used of 12 fiber MPO port. So in each MPO port there are 12 fiber. So how these 12 fiber means 6 fiber pairs. In 6 fiber pair, you can see 2 fiber pair is not used, only the 4 fiber pair is used. So how this 4 fiber pair is used in to connect internally means to make the circuit diagram, or you can say how these ports are internally connected so that it can perform the function of connecting RLS and CCMD. So we will discuss all these things in details. Let's see. So CFIM2 type 2, you can see this is the CFIM2 physical inventory. You can see MPO port 1, 2, 3, 4 is connected with 4 different RLS. So 1, 2, 3, 4, these 4 MPO port is used to connect 4 different RLS. And 5, 6, 7, 8. These 4 port we can use in two different ways. Either it is used to connect another 4 different RLA but of different quad group. You can see MPO port 5, 6, 7, 8 is connected with 4 different RLA of different quad group, or we can use 5, 6, 7, 8 with 4 different CCMD at cross 24 to drop some lambdas. The quad group of RLA which is connected to port 5, 6, 7, 8. So means you if we are connected to RLA from 5, 6, 7, 8 and 4 RLA from 1, 2, 3, 4. So the RLA, you can see the quad group of RLA which is connected to port 5, 6, 7, 8 is different with the quad group of RLAs which are used to connect 1, 2, 3, 4. So this is the rule. So CFIM2 is the crucial part of the RLS system. Basically, CFIM2 are the passive module, and hence it does not require any DC power and does not require any external power source or any electric current. You can see compact fiber interconnect module 2 is used to provide the pass-through interconnection between RLS in different degree quad group. As I have said that 1, 2, 3, 4, if this 4 MP port is used to connect R4 4 RLS, and 5, 6, 7, 8 is also used to connect the RLS. So these 4 RLA and these 4 RLA must be in different quad group. So you can see uh, you will see in the next slide this port 1 is connected to 5, 6, 7, 8. Port 2 is connected to 5, 6, 7, 8. 3 is connected to 5, 6, 7, 8. And 4 is connected to 5, 6, 7, 8. Internally, it is connected. So if you can see if one RLA is connected here, so it can communicate with all these 4 RLA of different quad group. This is the statement, like this is the CFIM2 is used to communicate or interconnect between different degree quad groups. It is used MPO cable to interconnect a group of 4 degree to another group of 4 degree. Yes. So this is for 4 degree, this is for 4 degree. So it is totally, you can by CFIM2, we can use 8 degree. It is used to airdrop interconnection between RLS and CCMD if you are using uh, four RLS with this MPO port and four different CCMD 8x24 with this MPO ports, then it can be dropped on the CCMD 8x24. Why this all four RLS? CFIM2 is a crucial part of the RLS system. So this is the same. It is used MPO cable to interconnect 4 degree of another group of degrees. At drop for CFIM2, you can see there are 8 MPO port which is used for degree interconnect, at drop interconnect. Loopback connector are required if no fiber is being installed. Otherwise, the connection validation feature will raise alarm. So there is a connection validation feature is introduced in this RLS system. So if any loopback connector is not installed, so it will face like open case, open circuit, and it will show the connection validation alarms. Any CFIM connector not equipped with a loopback module or fiber patch cord must be equipped with a test cap. CFIM2 is used to pass through traffic between different watt degree group. CFIM2 is used to add drop traffic. So these are the two basic use of the CFIM2. So let's see its connectors. You can see here MPO cable with 4 fiber is used. In CFIM2, 8 fiber is used among 12 fibers. In RLS switch port, 8 fiber used among 12 fibers. So if RLA is used to connect with the CFIM2, it means you can see RLA 4 fiber pair is used from the RLA and 4 fiber pair is used from the MPO 1 MPO port in the CFIM2. But if you remember in CFIM1, RLA only 3 fiber pair is used in RLA when it is used to connect with CFIM1. You can go in the CFIM1 video and check. So let's proceed. You can see here out 3. So three numbers of fiber is out. It is going to 10 number fiber in. 4 number is out is going to a 9 number in. 5 number is out and go to 8 number in, and 6 is out and 7 in is. In the same way, so if you can see, this is the 4 fibers and this is the 4 fibers. 6 is out is going to 7 in. 5 is out 8 in. 4 out 9 in, and 3 out 10 in. So this is the rule. You can see if you want to see any, you can see you can catch any port. You can, like if you want to see on this port, you can see this 3 is out, 10 is in. Here 3 is out, 10 is in. So 3 is out, 10 is in, and here 3 is out, 10 is in. So this is like the physical patching. Here this is the MPO port. Inside this is the 12 fiber pair. So this is showing you the sub fiber connectivity, but physically it looks like a single port of MPO port. Like this is the single MPO port. So let's see internal connectivity of CFIM2. NTK504QB is the back code. So let's see how is the internal connectivity inside the CFIM2. So you can see in CFIM2 there are 4 ports: MPO 1, 2, 3, 4, 5, 6, 7, 8. So now you can see port number 1, MPO port number 1 is connected by MPO port number 5 via one fiber pair. So MPO port, there are 12 fiber, means 6 fiber pair. So it uses 4 fiber pair to connect with 4 different MPO port. So one fiber pair of MPO 1 is used to connect with MPO 5. In the same way, second fiber pair is used to connect port number 6. Third fiber pair is used to connect port number 7. And fourth fiber pair is used to connect with port number 8. In the same way, you can see port number 2 is connected to 5, 6, 7, and 8. In the same way, you can see port number 3 is connected to 5, 6, 7, and 8. In the same way, MPO port number 4 is connected to 5, 6, 7, and 8. So this blue line represents the fiber pair, as I have already told. So you can see here, this is the MPO port. This is a physical MPO port, which is including 4 fibers, 12 fiber, or you can say 6 fiber pair. MPO port 1, 2, 3, 4, 5, 6, 7. So this is the internal connectivity inside. So now I have divided MPO port 4 into 12 different fiber. You can see just for understanding, because this is the physical port MPO 1, the physical port, and inside this there are 12 fiber pair. So you can see here MPO 1, 2, 3, 4, 5, 6, 7, 8. All MPO port has 12 fiber pair. So let's see. You can see 7 out, 6 in, 7 out, 6 in. Now this 8 fiber, 8 number fiber is out, is connecting to 6 in, not 6 in. You can say like 8 is connected to 6 internally. This fiber is connected with this fiber. In the same way, it is connected, 7 is connected with 5. 4 is connected to 6, and you can see 7 is connected to 4. In the same way, 10 is connected to 6 and 7 is connected to 3. So now you can see MPO1 is connected to MPO 5, 6, 7, 8. Now, whatever the signal which is coming from MPO port 1, it can travel to MPO port 5 via this fiber pair, 6 via this fiber pair, 7 via this fiber pair, and 8 via this fiber pair. So now you can see I have connected MPO port 1 to port number 5, 6, 7, 8. In the same way, I will connect MPO port 2 with 5, 6, 7, 8. You can see by this fiber pair, it is connected to MPO port 5 by 5, 8. You can see uh, this MPO 3 is connected to MPO 5 and MPO 4 is connected to MPO 5. Now you can see MPO 2 is connected to MPO 6, MPO 7 is connected, MPO 2 is connected to MPO 7, and MPO 2 is connected to MPO 8. Now MPO 3 is connected to MPO 8 and MPO 4 is connected to MPO 6. Now MPO 3 is connected to MPO 7. MPO 3 is connected to MPO 8, and you can see MPO 4 is connected to MPO 7 and MPO 4 is connected to MPO 8. Now you can see MPO port 2, whatever the signal which is coming on MPO port 2 can travel to MPO port 5, 6, 7, 8. Whatever the signal coming to MPO port 3 can go port number 5, 6, 7, 8. Whatever the signal coming from port 4 is can travel to MPO port number 5, 6, 7, 8. So whatever the equipment or whatever the fiber is connected, whatever the MPO port is connected to MPO 5, signal will go through that device. So this is the internal connectivity of CFIM2. Hope you will understand. If any confusion, you can comment. So let's see further. CFIM2 used for add-drop interconnection between the RLS and the CCMDs. So now you have already seen the internal connectivity of CFIM2. So let's see how the CFIM2 is used to interconnect the RLS and CCMDs. So let's see. Here's the CFIM2. These are the MPO ports. So I have taken 4 RLA, RLA A, RLA B, RLA C, RLA D. So it is the switch port of switch port 28 for RLA A, switch port 28. I have taken the switch port 28 of all the RLA A, B, C, D. This basically the switch port you can draw via any switch port, but we will recommend you to use switch number 28 to drop the signal. So whatever the signal which is coming on switch port 28 can be dropped on the CCMD 8 cross 24. Let's see how it is connected. So these are the 4 RLAs in first quad degree, and you can see this is the MPO port, a common port of MPO port. You can see 101, 101 COM A is the port of CCMD at cross 24. You can see here, this is the second CCMD4. This is the third CCMD 8 cross 24. You can see this is CCMD 8 cross 24A. This is CCMD 8 cross 24B. This is CCMD 8 cross 24C. And this is CCMD 8 cross 24D. So as you already know, if you don't know, you can see the RLS component video in which it will show like in CCMD 8 cross 24, there are two MPO ports, 101 COM A and 102 COM B. So first port is used for first 4 degree and second is used for another 4 degree. So we will show in some different video, but here now we'll focus how this first degree quad RLAs can be dropped, circuit from this RLA can be dropped on CCMD 8 cross 24. So I have taken this 101 COM A port. So you can see these are the MPO port. I have shown you the fiber, different fibers in the MPOs. So let's see how the signal is going to flow. So now you can see from CCMD 8 cross 24, this MPO port is connected with CFIM2 port number, MPO port number 5. So 6 is out and 7 is in, you can see. Now 7 and 6 is internally connected via the CFIM2, and this MPO port 5 is connected via MPO port 1. So from this MPO port, this switch port 8 of RLA is connected. So whatever the signal going by this fiber of this MPO port of this CMD cross 24101 will go to this RLA switch 28, this fiber pair. You can see 6 is out, 7 is in. In the same way, reverse direction, you can see this is like the connectivity. So you can see from this sub fiber. So whatever the signal coming on RLA switch port 28 by this sub fiber, it is going on say CMD8 cross 24A. Now you can see second fiber pair. This fiber this fiber pair is connected via this, and this is going to RLAB switch 80, switch 28. In the same direction, it will flow like this. So you can see from CCMD8 cross 24A via this fiber pair, it is going to RLAB. Now let's see via the third fiber pair. Now you can see via the third fiber pair, it is going to RLAC switch port 28. So in the same way, whatever the signal which is coming on switch port 28 via this fiber will go on CCMD cross 24A. Now let's see four fiber pair, it is going to RLAD. So now you can see via this CCMD cross 24, we have four directions, to RLA, to RLAB, to RLAC, and to RLAD. So this is the MPO port. So via this fiber pair, green fiber pair, CCMD8 cross 24, the signal can go in this direction. Via another fiber pair, it is go in second direction, in third direction, fourth direction. So you can see from this port 101 port, we can achieve 4 degree. In the same way, 102 which is the another MPO port of the CCMD8 cross 20, we can achieve another 4 degree. So CCMD8 cross 24, we can achieve 8 degree. So this is like the connectivity. So now let's see from the second CCMD8 cross 24B, this fiber, you can connect via this fiber pair and go to RLA in the same way. So you can see always 6 is out, 7 is in, 6 is out, 7 is in, here 5 is out, 8 is in, 5 is out, 8 is in. So this is connected. This CCMD8 cross 24 via this fiber pair, it is connected to RLA. By the second fiber pair, you can see it is connected to RLAB. In the same way, by the third fiber pair, it is connected to RLSC. You can see by the fourth fiber pair, it is connected to RLAD. Now, third, you can see the CCMD8 cross 24C. By this fiber pair, it is connected to RLA. By second fiber pair, it is connected to RLAB. You can see the signal flow by this arrow. By third fiber pair, it is going to RLSC. By fourth fiber pair, it is going to RLAD. Now, CCMD8 cross 24D, by this fiber pair, it is connected to RLA. By second fiber pair, it is connected to RLAD-B. By third fiber pair, it is connected to RLSC. And by fourth fiber pair, you can see it is connected to RLAD. So now you can see if we are using this RLA, for every direction, one RLA is used. You can see for every degree or direction, one RLA is used. So whatever the signal which is coming via this direction or coming on this RLA can be dropped on any of the four CCMDs via this CFIM2. And from CCMDs, it can go to any four direction via internal connectivity of the CFIM2. You can see. So CCMD cross 24A can be go in any direction. This CCMD can be go in any direction. This CCMD 8 cross 24C can be go in any direction, and fourth one can be go in any direction. So this is like the connectivity and signal flow between the RLA and CCMD 8 cross 24. Hope you understand. If you have any doubt, you can ping me in the chat. CFIM2. Now I have we have seen the CFIM2 connect, how the CFIM2 is used to connect the RLA and CCMD. Now we will see how it is used to pass through interconnection between RLAs of different degree quad. So in the same way, we have taken this CFIM2 MPO port 1, 2, 3, 4, 5, 6, 7, 8. Now you can see here is the RLS, these four RLS of the second quad degree, or these four RLA in the same quad degree. And you can see from MPO port 5, 6, 7, 8. So previously we used to connect MPO port 5, 6, 7, 8 with CCMDs. Now we will connect these MPO port with another four RLAs of different degree quad. So you can see this is the first quad group, this is the second quad group. So it means these four RLAs in another quad group and these four RLA in another quad group. So in the same way, like the CCMD in the previous slide, you can see previous slide where the CCMD is used to connect all the four RLAs. In the same way, these RLA can be used to connect these four RLA, and these four RLAs are also used to connect all these four RLA. So what happens? These four RLA of same quad group degree quad group can be communicated with another four different RLA in the different quad group. So let's see. You can see why this for fiber of the why this for fiber, this RLA is connected to this RLA. RLA A is connected to RLA E. Why second fiber pair RLA A is connected to RLA F. By third fiber pair RLA A is connected to RLA G. You can see the signal flow. By fourth fiber pair it is connected to RLA H. So what happened? There is the interconnection of these four RLA to this RLA. So this RLA, you can see RLA A can be communicated in all the four RLA of the other quad degree group. In the same way, RLA B, you can see, can be connect to RLA E. RLA B can be connected to RLA F. RLA B can be connected to RLA A. You can see here by the fourth fiber pair, RLA B can be connected to RLA H. Now RLA C can be connected via the RLA E. By second fiber pair, you can see it is connected to RLA A. By third fiber pair, you can see it is connected to RLA G, sorry, and by fourth fiber pair, you can see it is connected to RLA H. In the same RLA D, by first fiber pair, it is connected to RLA E. By second fiber pair, it is connected to RLA F. By third fiber pair, it is connected to RLA G. And by fourth fiber pair, you can see it is connected to RLA H. So all RLS can be communicated with each other. So CFIM2 connectors, let's see. This is the comparison of CFIM1, CFIM2, CFIM3. This is the pack code. These are the power budget. These are the same weighted. These are the return losses of the same. So at the end, we can summarize the and the meaning of CFIM2. CFIM2 used MPO cable to interconnect a group of 4 degree to another group of 4 degree or adopt the interconnection between ROADMs. Function, it plays a crucial role in enabling flexible connectivity within the 6500 RLS architectures. CFIM2 is essential for managing traffic between different parts of network, allowing for dynamic routing and efficient utilization of resources. CFIM2 bridges groups of degree and add-drop connections. So this is all about the CFIM2, its internal connectivity, its connection between RLAs, its connection between RLAs and CCMD 8x24. Hope all of you understand about this. If any doubt, you can comment and I will try to explain that. Thanks for watching.